Hey everyone, welcome back. I am Vivek Bharata, and today we are diving into a problem that every real world distributed system faces, ensuring consistency across microservices. Have you ever wondered how banks make sure your money isn't lost mid transfer? Or how large e scale apps coordinate actions across services without a central database? That's where Saga Pattern comes in. In this video, we'll implement the choreography style Saga Pattern in our VBank application, a real world scenario involving financial transactions and multiple microservices. Imagine this scenario. You want to transfer $100 from account A to account B. Sounds simple, right? But in a microservices architecture, this involves at least two separate services. First, the transaction service creates and tracks the transfer request. Second, account service, which actually handles account balances. Here's where things get tricky. What happens if money is debited from account A and credit to account B fails? The transaction is recorded, but the account balance is never updated, or even crash happen on microservices at any stage. Traditional asset transactions don't work across services. We need something better, right? Enter the Saga pattern. The Saga pattern breaks down a distributed transaction into a sequence of local transactions, each with compensating actions to handle failures. Think of it as a series of steps with built in undo capabilities. Not really an undo, but like a compensating capabilities. Let's look at how we will implement this in our VBank application. Starting with the transaction flow, user initiates transfer, transaction service creates a transaction record with initiated state. Account service debits source account and then it credits to destination account, and at the end transaction record marked as completed. Now imagine step 4 fails somehow. Then compensation flow kicks in where it roll back the debit from step 3, which technically credits again to the same account, which is a compensating action, and mark transaction as failed. So here are the very high level implementation design steps. First, we are using a single Kafka topic, transaction.events, for all transaction related events. We are defining clear event types for each stage of the transaction. We are implementing compensation logic to handle failures, and also we are improving logging and error handling. Wait, why a single topic? Hold that thought, we'll explain later. Now let's focus on the core Kafka events, the heartbeat of the saga. As you can see, there are different event types which represents different phase of the actual transfer. First one is initiated, then account debited, and in case if account debit failed, then account credited, and in case if account credit fails as account credit failed, and account debit compensated to compensate the actual account credit failed scenario, and a date completed as a final stage or failed in error case. Each of these events represents a state transition in our transaction saga. Our transaction service kicks off the saga. It receives an API request from users, creates a transaction record, publishes the initial event, tracks the transaction state across the whole saga pattern. As you can see in the code snippet here on the transaction create function, inside once the transaction has actually saved into the DB, we are publishing an event as publish transaction event with event type as initiated, which will be consumed by account service. I'll cover the account service as well in high level, then we can jump onto an actual code implementation walkthrough. The account service has the critical job of actually moving the money between accounts. First, it listens for transaction events, updates account balances accordingly, publishes success or failure events, and handles compensation if needed. This account service acts as both Kafka producer and consumer in our event-driven flow. Now let's jump on to the actual code implementation detail. If you followed from the beginning of this microservices series, I already have this account service API gateway and auth service. I just created a transaction service in the same pattern of either account service or auth service. I'll just give you the very high level changes that I implemented on the transaction service. Let's start with the transaction entity file, which gives you a better picture of what are all the fields we'll be storing. And in this transaction service, for now, we only have one specific table, that is transaction. Simple. Okay. Now we have the fields accordingly. ID self-explanatory. Then we have user ID, the one who actually requested the transfer, and the transaction ID. This is actually being generated over here with a specific pattern. Nothing fancy. I'm just creating a UID and just removing the hyphens, and I'm just adding vbank as a prefix. And the specific function acts as a before insert hook with this specific decorator before insert. Now resuming to the other field definitions. And then we have most important fields: source account number, destination account number, transaction type, whether it's a transfer, credit or debit, and then transaction status. This has a lot of fields like initiated, debit, success, and so on. And the other main important field, amount over here, and simple note as string just to store any other meta information. Reference ID, which I'm not currently using it, is internal or not. This will be the main field. Maybe in the later videos, if we want to cover external transactions, then this will be false in that case. And this details field is important during the error scenarios where we will add more data in this field. So these are all the different date fields across the different stages, like completed it, source debited it, destination created it, compensated it in case if needed. And then we have this default created it and updated it. That's it. So this is the overall rough fields that we are doing it for the transaction entity. And in the transaction service, we do support two routes for now. One is post with transfer as an endpoint, and the next is get with the transaction ID. Simple for now. We can actually have many different routes, like the list of transactions for a specific account number and all. For now, to make it concise, I feel these two are more than enough. And moving on to the transaction controller, this is like specific to these routes. So in the transfer, this is important. Over here, if you see, we are trying to basically again parse with transfer schema. If you see, this is a sort schema. Over here, we have some validations. And then later, once we properly parse it, I'm calling the transaction service create method, where I'm passing all the details and also transaction type. Just for now, we are covering it as simple transfer. That's pretty much it for the transfer endpoint. I'll go through transaction service soon. And then we have this get by transaction ID, get the transaction ID from the route parameters, and then trying to get the transaction object from the transaction service. By this get by transaction ID function. And also I have a very simple basic authorization check here, like the requested user ID actually owns that specific transaction record. Now let's move on to the transaction service. As you can see, we have this create here. Once I get the data from the transaction controller, I'm basically trying to construct all the required fields accordingly, and then I'm just calling transaction repository save. So this specific line basically creates a record in the database. And then later, this is very important, this is technically the entry point for the Saga pattern. As you can see here, publish transaction event. Here I'm passing all the meta information. Event type, right now it's initiated, right? As this is the very first step, if you see here, the transaction status is initiated. So to align with this status, I'm passing event type as transaction event types initiated. So this specific event will be consumed by account service and starts the actual money transfer between accounts. Okay, so this event with this event type transaction initiated will be consumed by account service and starts the actual money transfer. And I'm passing other meta information like user ID. Transaction ID is very important because we'll be using transaction ID as a key when we produce a message to the Kafka topics, so that any messages in reference to this specific transaction ID will always end up in the same partition, so that order is always maintained. This is the main advantage of Kafka. If you need more dive deeper into how the Kafka works, go through my Kafka 0 to Hero series. Alright, then later we have the status as initiated, source account number, destination account number, because all this meta information is needed for account service, because account service needs like what are the account numbers from where it should transfer, right? So all this meta information and also amount, of course, and the transaction type. For now it will be transfer, that's it, and is internal as well, that's it. So this is the all the meta information we are passing to account service. This is all about the create method, and if you look at the get by transaction ID, I'm just passing find one and passing the transaction ID, that's it. And finally this update status function, which is mostly used across the whole Saga pattern flow, because we keep updating the status of the transaction record. And if you look at the signature over here, it's only one argument as an object, and it accepts the status, error details if any, source debited it, destination created it, compensated it, and completed. All are optional because we'll be using the same update status function to update across the different transaction events. Here is basically the fallback status I'm just using. That's pretty much it. I hope till this part it's clear. We covered the main primary files in the transaction service, and this publish transaction event in create method, which is an entry point for the Saga function, which is simply a producer function we defined in this transaction events.producer. I'll just go through this over here. In the transaction service, if you see, we have the same pattern. So in the events, earlier we just covered till producers, I believe, so I added the consumers as well, right? Simple. So in the producers over here, if you see, and this is the function where we are calling over here in the transaction publish transaction event. Okay, so here if you see in the event data, I'm actually using transaction ID as the key. This is very important for to maintain order in a specific partition. And in the value, I'm just spreading the event data and I'm just adding the timestamp. That's it. And moving forward, we'll just simply use this function to produce any messages. That's it. And also in the consumers pattern, I think this is the very first time. This also falls under the similar flow, but the only change is like over here, I'm just calling start transaction event consumer and creating a consumer over here as TS transaction event CG. And this notation is basically to make it a bit shorter. TS is transaction service, like which transaction service this is, transaction events as the topic, and CG is nothing but consumer group. Specific line consumer.connect basically connects to the Kafka broker, and I'm subscribing over here. So the topic is transaction events and from beginning is false. And also I did make some changes in the packages because we need this transaction topics also in the constants, if you can see over here. transaction topics, transaction events. And this create consumer is an internal wrapper to our actual Kafka client.create consumer, and we are just accepting group ID. That's it. Okay, I hope this is clear. And here, let me close the sidebar. So this is important. So inside the consumer.run, we have this each message. So basically for any message it consumes, this whole function body will be executed from 19 to 90 line number. Okay, all this will be executed. So before continuing the consumer definition in transaction service, I think it's better to start from account service. Reason, as you're publishing in the transaction service, this specific event will be consumed in the account service. So let's actually go to the account service consumer over here, transaction events.consumer, which is in account service. So here also same. So create consumer, the consumer group name is basically AS as account service, transaction events as the topic, and CG is consumer group. The most important field in this whole Saga pattern is this event type. Reason, if you look at the transaction events.consumer, we have simple switch case and we are relying on the event type. So based on the event type, whether it's an initiated, account debited, or account created field, based on that we need to do some specific action, right? So the very first and foremost is, so transaction service will produce a message to this topic, transaction events, and the event type will be initiated. So the first entry inside the account service is basically this specific case, transaction events.initiated. Okay, in that case I'm just having the specific handlers. So handle transaction initiated. So if you look down over here, handle transaction initiated, it's basically extracting all the required information like transaction ID, source account number, amount, and transaction type. And based on that, if transaction type is not transfer, I'm just basically throwing. So the moment we receive this initiated event type, we basically try to debit from the source account. So source account number, as we're extracting from the event data, I'm basically trying to do update balance. Account service.update balance. The first argument is basically the account number from which the money should be debited, and the transaction type is debit, and we are just passing the amount. And inside, if you look at the pattern, this we already covered, but I'll just cover on high level. I just added this one small tweak. I'm always making sure the amount is absolute. For let's say if the account is not valid, I'm basically throwing an error, so that will be consumed over here. We have this try catch over here. So publish transaction event, I'm actually sending the event type as account debit failed. Whatever the reason, so whatever the reason, I'm just passing that as over here, and the error code also. Simple. Okay, so that's how the overall update balance will make sure that if the account number is invalid, we'll send this account debit failed as a separate event. Okay, so for now let's cover the whole positive scenario. So assuming that the source account is valid and the amount is actually debited, then account service is actually publishing a message to the same topic, but the event type this time, if you see, this is account debited. Okay, and I'm just passing the source account balance at that time. Let's say if the account balance is 1000 and the current transfer amount is 100, then in this case the value will be 900, because so this source account object will hold the after debit, so ideally the value will be 900 over here. And I'm also passing source debited. The reason I need to pass from here, we can't just use it on transaction service because there will be a slight delay. So it's always important, whenever you're passing any date fields, make sure you always pass the date fields at the producer level but not at the consumer level. So till this part I hope it is clear. So in the account service we're actually debiting, nothing after that, so we are not actually creating. So what we're trying to do is, once the actual debit is successful from the source account, I'm just publishing an event. Simple. Now the specific account debited will be consumed at two places. One, in the account service itself to resume the Saga pattern to create into the destination account, and also transaction service also consumes this message and tries to update these values. So let's start with the transaction service consumer over here. So in the consumer, if you see, we have this account debited, and here I'm just passing update status. Status is like debit success, and source debited, and the source debited at value is actually coming from the account service over here. So now apart from this, as I mentioned, the same event is actually consumed by the same consumer. And if you look at the switch case over here, we have this account debited. See, this and this is same account debited. So single message can be published and consumed in the same microservice. It's kind of a pattern, and it's kind of a good pattern not to bottleneck the whole service. We have this account debited. Now if you look at the pattern, also we have a specific handler here. If you see, handle account debited. And now if you look at the definition, if you can guess, we basically try to credit into the destination account. So transaction ID, destination account number, and amount. We're actually passing the whole event data, whatever we received in the before messages over here. So at any point of time, any handler is consuming the event data, it has all the required information, but we can just pick only specific fields. So in this case, I'm just picking transaction ID, destination account number and amount. That's it. And now I'm trying to update the balance with the type as credit. So destination account number I'm passing and I'm passing the amount. So let's say if this is successful, and again I'm publishing an event stating that account credited. Simple, okay? And I'm actually passing destination account balance and destination credited. Now if you can guess, this account credited is again will be consumed over here, account credited. Update status completed, destination created it and completed also I'm passing. That's it. Because in this case the account created, if it is successful, then usually destination created it and completed will be same because the whole transfer is completed. So we can use the same date field. Simple, okay? Now let's go back to the account service. Now assume that there is some issue with the credit. So there could be many reasons. Let's say this destination account number is invalid. So if you look at the update balance over here, if the account is invalid, I'm just throwing an error, account not found, right? So now assuming that the account number is somehow it is wrong, we can actually check this in the transaction service itself, but we need to call an API. So I'm thinking down the line I'll be using gRPC to basically get the account validity before even starting the transaction, right? So that's like a better approach. I'll consider it in the later videos to include the gRPC. Alright, now assume that this destination account is invalid. Then basically it will be captured in this catch block. And here if you see, we are again publishing a message simply stating that account credit failed. Now if you can guess here, account credit failed again will be consumed in transaction service. Over here, oops, account credit failed. And I'm basically constructing the credit error and error code, and I'm using that as a error details. And this error details is actually set inside for the details field over here. Now if you just go one step back, so account credit failed, in the transaction service I'm not doing much because I'm just trying to set the transaction record by calling this update status. But if you observe here, this transaction events consumer in the account service, okay, also listens to the same published event type, that is account credit failed. Reason, we need to compensate the actual debit happened. So if you look at the pattern over here, we will consume that also. Here account credit failed. For the account credit failed, I'm actually having a switch case over here as a handler also. So handle account credit failed. So in this case we need to compensate. So what we can do, basically trying to credit into the source account number. This is important, right? Because we are trying to undo. It's not kind of an undo, but basically adding the same amount what we debited. So source account number, transaction type dot is a credit. If you observed earlier, for the debit actually we use this same source account number, but the transaction type is debit to actually debit. Now to compensate we need to credit back, right? So that's the main change over here in the compensation logic. So once this is successful, let's say, then in that case I'm again passing account debit compensated. So this account debit compensated is again captured in the transaction over here, account debit compensated, and based on that I'm updating the values accordingly. That's it. And in here if you see error details, I'm actually passing that as event like account debit compensated, but overall the transaction status will be failed for the later auditing purposes and all. So now if you see, this is one case, and assuming that this compensation is actually failed, then that's like a bigger problem. As we consider all the error cases, this also will be possible, like the compensation is actually failed. So in that case we can raise an alarm by sending a notification email or Slack or any integration part, and from there admin can step in and do the manual activity. I believe that's all we covered, I guess. So maybe if you look at the transaction service, so in the transaction service we have all the events, and also if you see account debit failed, in this case compensation is not really required because the source account number might be invalid. So in that case we can just simply mark as status failed and event as account debit failed, and error and all we can just send as is. That's it. And also one important note, in the previous video where I explained the theory part of the Saga, I mentioned it as a topics. Reason, like I was assuming that we can do the different topics. It also works with the different use cases, but in the specific use case when I was trying it, it did fail. So I'll just cover that in the later part. But in short, I'm just consuming only one topic, and based on the event type that we pass it on over the payload, I'm actually handling with a simple switch case. And also if you notice, as both transaction service and account service both are consuming from the same topic, it can actually pick the same messages what it consumes. Usually it is the business logic in account service, because if you see in the transaction event consumer side, account credit failed, this account credit failed is actually being consumed in the same consumer. If you see account credit failed, and also for the account debited to resume the step to basically credit into the destination account, right? So in the default case, I'm just adding a ignoring event type because both in account service and transaction service, I'm actually producing and consuming to the same topic. So usually the same consumer can pick the unnecessary events based on the event type. So we can just log in message for now like unhandled event type so and so for transaction as transaction ID. We can actually skip this part and just make it as an empty default. But for now, for a clear visibility, I just added this. I hope all this implementation detail is clear. I know this might be kind of an overwhelming, but overall it's actually simple once you start implementing it. So try it out for a whole week and see if you can try to crack this out. Anyway, I'm going to publish this branch so you can refer. Alright, so that's a very high level walkthrough. Let's spin the services and actually trigger some requests. Okay, so all the services are up and running. If you see, API gateway is running at 3000, auth service at 3001, and this is account service, and this is transaction service. So 4 terminals across. Okay, now let's open Bruno and see if I can use the same accounts. So for that, before I'll just call get list of accounts, see if I can unauthorized. Okay, maybe the token got expired. So let me just quickly log in. Auth login. Alright, I got the token. Now I'll just do. Okay, so as you can see here, API v1 accounts. So I have 2 accounts for now. So current account and have the savings account. Okay, and ignore this account name, that's basically the default value, but account type is important. So account type is current, and over here account type is savings. Okay, now in the current account we have 19,700, and in the savings account we have 300. Okay, now let's go to the transaction post request. Over here, if you see source account number, destination account number, I can just quickly verify. So 7556 is basically the source account number, 5542 is basically the destination. So on the transaction, if you see 7556 is source and destination account number is 5542, and I'm passing amount as 100 and maybe note as gift. Okay, now if you just send, alright, so initiated. Now what I can do, I can just call this detail. I also have this script, PostgreSQL, basically this latest transaction ID, I'm just giving it as an environment variable, and I'm extracting this from the body. Okay, I can just go to detail. As I already have this latest transaction ID as a variable, I can just simply trigger. As you can see here, status is completed, transaction type is transfer, amount is 100, note also came as gift, reference ID is null, we can ignore that for now, is internal is true, details is empty, completed it, source debited it, destination created. As you can see, there could be at least some microseconds difference. As you can see here, 38.311z and here 38.327z. Okay, and compensated is null because there is no error scenario, created it and updated it. Simple. And I'll go through the logs now, and if you can see here, this is the transaction ID, right? So I'll just copy this one and I'll open over here. This is account service. So if I try to search over here, let me see if I can just expand. Okay, I'll just start from the very beginning. If you can see here, processing, initiated event, transaction. Okay, and then later publishing message to topic, transaction events with message so and so. And if you look at the event type over here, I'm not sure whether this is clearly visible, account debited. Simple. Okay, this is inside the account service. And then later, if you look at the pattern, processing account debited event for transaction. So the same account service is actually consuming the same event, account debited event for transaction, and then trying to credit into the destination. Okay, and once it's done, if you see, I'm passing event account credited over here. I know this is kind of a tricky, I'm not sure whether this is really helpful, but if you see here, we have this event type as account credited. Okay, now if you look at the transaction service, okay, I'll just try to search it. Maybe I'll expand over here. And if you start from the beginning, so the first one is transaction initiated over here, and then later publishing message to topic and event type is initiated. Simple. Okay, and then later processing initiated event, and if you see unhandled event type initiated, because as it's the same topic, this will also consume, but as I mentioned a while ago, this comes under the default switch case. That's it. We were not basically processing anything, we'll just consuming it and passing. That's it. And then later, if you see processing account debited event, basically trying to set the transaction state as a debit success. And then later, if you see account created event, so if you pattern account debited event, then account created event over here. The moment we got the account created, I'm marking that as completed. That's it. Okay, now let's look at the error scenarios now. So what we'll do in the transaction, let's give some extra number as 1 at the end for source account number. So this should fail. Okay, I just triggered the request as status is initiated. Now if you look at the detail and see what's the final state. So if you see status failed and details here, event account debit failed, account not found. Simple. Error code as E0. I can also actually add the source account not found or something, but it's self-explanatory because the event is account debit failed, right? Basically the source account not found. That's it. Okay. Now if you look at the pattern over here, so in the account service, if you see fail to process transaction, for the VBank, if you see 99 FEC, if you verify 99 FEC, that's it. Okay. Now let's actually test this Saga pattern, right? Now let's actually change the destination account number something else which is not valid. So in this case, the source account number gets debited, and due to this destination account number is invalid, we usually need to compensate that logic, right? So let's trigger this request. Okay, initiated. Now looking at the details. Okay, status is fail, right? And details, if you see event account debit compensated, clear. And also if you see destination created it, because it's not even valid, so destination created event is null and compensated it value is there, if you see here, right? So that's it. Now let's look at the pattern in the logs. If I search over here, if I just go back, so if you clearly see account debit compensated in account service logs. Okay, in the transaction service, if you see account debit compensated, and also previously you should also see account credit failed, because once account credit is failed, you will basically account service will try to compensate and fail to create account so and so, and then later account service will emit an event stating account debit compensated, and the same event will be consumed in the transaction service and basically updating the status as create failed over here, and then later update to failed. That's it. I know this might be kind of an overwhelming with so many event types and all, but try to implement the same with a very basic servers. Once you complete the whole flow, you will get a better understanding. Now at this stage, we just tested with the manual REST calls. Now let's cover the end-to-end test cases. So I updated the end-to-end test cases over here if you are familiar with the previous changes. So in this complete flow test, I added total 4 more test cases. So transfer money between internal accounts should success, then transfer invalid source account number should fail, invalid destination account number should fail and compensate, which is important, and transfer insufficient funds should also fail. Simple. Okay, now if you look at the pattern, it's simple. So what I'm trying to do is I'm just passing the amount as 1000, which will be actually valid, and I'm just having a small promise interval with an interval frequency of 1 second, where I'm trying to see every second whether the status is completed or not, and also all the different date fields are also valid or not valid, and so on. That's it. So this is like the transfer money between internal accounts should success, and in the source account number should fail. I'm actually checking over here. Yeah, so status should be failed, and also source debited to be null, destination created to be null, because in this case the source account number itself is not valid, right? So all the date fields should be null except the completed, because as the transaction is also failed but it is completed state overall, right? So we need to make sure that completed value is actually not null. Simple. Similarly, we have other 2 test cases where invalid destination should fail and compensate. So in the compensate, I'm explicitly checking whether compensated at field should not be null over here. So source debited it, compensated it, and completed it not to be null, all these 3. Destination created to be null because the destination account number will be invalid in this case. That's it. So how I'm passing the invalid, I'm just adding some dummy 001 at the end. Simple. Okay. And in the insufficient funds, I'm just adding 1 million, I guess. So that's pretty much it. Okay, so let me just run these test cases quickly. E2vitus npm test. Okay, all 30 passed. As you can see here, these 4 test cases are added. Transfer money between internal accounts, invalid source account should fail, invalid destination account number should fail and compensate. Insufficient funds also should fail. Simple. Okay, that's pretty much it on the overall implementation detail of Saga pattern. I'll just show you in the Kafka side also. So transaction events, as you can see, we have 319 messages. This was all my internal dev testing also, I believe. But inside, if you see the pattern, we have the 10 partitions, and each partition next offset were like all different, because we have based on the different transaction IDs, we are passing across different partitions also, right? So that's all. Maybe in the newest first, if you see, so account debit failed, User ID, transaction ID, status is initiated, transaction type is transfer, is internal is true. I think status we keep passing it as initiated. We can just change this one, but for now I think that's fine. It's an internal debug maybe, yeah. But overall, as you can see, that's how the message has been spread across different partitions. So partition 7 over here. So for the same transaction, it will always be 7. So let me just see if I can open another one. So over here, if you see, partition is 9 for this transaction ID and partition 0 for this transaction ID. So all the different messages. And consumers also, if you see, we have two consumer groups and only one active consumer because we have only one instance for each microservice, like transaction service one instance and account service as another instance. So AS transaction, this is basically account service consumer group. TS transaction events is basically transaction service consumer group. That's it. And also earlier we have this master test.ts, which is basically a static way of referencing and maintaining the order of test cases. But I actually improved that and added as a custom sequencer, which is part of the jest only. So over here I'm passing this as these in this order, test order, health check, and all these are basically the files over here. And this custom sequencer basically makes sure that these files are run independently one by one. So in the previous case over here, if you see, all these test cases basically runs as a one single unit of operation, which is not really a good way because down the line we might have so many test case files. So it's better to use custom sequencer so that each test will act as a one single unit of operation. But in this case, all four will be part of a one single unit of operation, which is actually bad. So this is one other improvement I did as part of this change. So overall, key takeaways and best practices. So event driven architecture is perfect for implementing sagas, and we have this compensation logic should be carefully designed and tested. Monitoring is essential. Track every step of your sagas. Right now we don't have any proper log monitoring and observability. Down the line we will be adding that as part of the series. Right now it's kind of a struggle, right? We basically search the transaction ID from the logs itself. That is actually only for the very early stage of the development. So in future we'll be definitely adding the log system and also monitoring and observability. So let's discuss about this specific point single topic in the next slide. What is the learning from my own internal development? What actually went wrong with different topics? I actually tried with different topics for each event type. I guess that's how I explained in the previous video. Well, I am partially wrong. Reason? While testing that approach, I faced issues on the order of messages, as account service should publish and consume same messages, which causes order of events per transaction ID, and transaction record status fields and other fields are not set correctly, which I actually found out while running end-to-end test cases, which again saved a lot of time as an early detection. Then I again brainstormed and realized it's better to use a single topic for this use case. So with this unified event topic approach, so we have this ordering persistence. Events for a single transaction are guaranteed to be processed in order because we'll be passing to the same topic, and the same transaction ID will be sent into the same partition. So order will be persisted. So with a single topic, we have the simplicity because we can easily track and debug the transaction flow, and consistency of course because single consumer pattern for all transaction events. So at this point you might be wondering whether the internal bank transfer use case is the best way to demonstrate the Saga pattern. Honestly, I had similar thoughts during development. The banking domain, especially the internal bank transfer, isn't the most common choice for demonstrating the Saga pattern, especially since e-commerce use cases are widely covered in the microservices world. But I wanted to explore something different. I felt that the banking domain would offer fresh learning opportunities both for myself and for you as a viewers. Now to make the Saga pattern even more relevant, I'm introducing external transactions. This means we are not just dealing with transfers between internal accounts at VBank application. We'll also handle outbound transactions where the destination account is outside VBank and inbound transactions where the source account is external. This extended use case builds on the existing setup with minor tweaks to accommodate the external transactions, making it more applicable to real-world systems that deal with external dependencies. One thing we observed during testing is that checking the order of events through logs isn't ideal for real-time applications. To address this, we'll be integrating monitoring and observability into the system to ensure we can track and respond to events more effectively. With these updates, our VBank application is now able to process transactions reliably across multiple microservices. Even in the face of failures, we maintain data consistency and avoid losing money. Whether you are building a banking app or an e-commerce platform or any other system that requires reliable distributed transactions, the Saga pattern we have implemented here provides a strong foundation. If you found this deep dive valuable, please don't forget to like and subscribe. Drop your questions or suggestions for future topics in the comments. Thanks for watching, and I'll see you in the next one.